All right, guys, welcome back after that short advert break. Let's continue with our lesson. In this section of our lesson, we'll be looking at the probability scale. Okay, so let's see what the probability scale is. So I indicated here that the probability scale is a scale which can be used to plot the probability of an event happening, right? So, guys, again, this may seem simple to you, okay? But remember, you need to know this, right? Because we're going to apply this basic concept when we go to our application topics. Okay, and also remember, within mathematical literacy, we don't have any question that counts 1 mark. So you can't afford to throw away easy, simple marks. So let's quickly get familiar with the probability scale. So here, I've indicated starting at 0%, as you can see here, right, all the way up to 100%. Now, if you look back at what I said earlier on, we said probability can be expressed as a percentage. And here you can see all your percentages, right? 0, 25%, 50%, 75%, and 100%. It can also be expressed as a fraction, right? And there we have our common fractions there, starting at 0, 1/4, which is a quarter, a half, 3/4, and then obviously 1. And I also indicated probability can be expressed as any number between 0, here we can see, and 1, right? And then lastly, I also indicated that it can be a decimal number as well. Here we can see 0, 0.25, 0.50, 0.75, and 1, which all represent the same thing, right? Just the different notations. Okay, so what else is important here? Okay, when I'm at 0%, it simply means that the chances of something happening is impossible, right? So that is definitely impossible. Then if you look at 25%, right, remember the equivalent of that will be a quarter, and as expressed as a decimal will be 0.25. Why am I noting all of this? You'll see as we progress with this lesson, sometimes we can ask you to express the probability either as a percentage, as a fraction, or as a decimal. Hence, it's important for you to know all these different notations. Okay, so this here, if I look at the 25%, right, that's less likely for something to happen. Okay, and I want you to listen carefully. After this, we're going to put this into practice. Then, if you look at equally likely, that's why we call it 50%. And I want you to think of an example. Let's say, if I have a coin, right? When I flip that coin, there's a 50% chance that it can either be heads or that it can be tails, right? Therefore, we are saying it's equally likely. Then here, if you look at 75%, meaning now your chances of something to happen becomes more likely, right? So 75%, 80% upwards, it's more likely for something to happen. Okay, here we'll say it's less likely, right? So if you look at 25%, so I'm just going to indicate to you that's less likely for something to happen. And then obviously if it's 100%, okay, then I can say it's certain. I can say with certainty that whatever the case may be, it is 100% possible for that event to occur. Right, so I hope that is all clear to you. Okay, now let's quickly look at the next slide. So here, I said the probability of something happening can be described numerically using a probability scale from 1 to 0, right? Then what else is important? This is basically a summary of what I've explained on the probability scale to you just now. I also indicated here that a probability of 0 means that it's impossible for the event to happen, okay? Then a probability of 1 or 100% means that it is certain that that event will happen. Right? 0 means impossible. 1 or 100% means it's definite, it's certain. Then, if an outcome has an equal chance of happening or not happening, it has a probability of 0.5. Remember, as a decimal, that means a half, right? This can also be expressed as 1/2, which is a half, or when you go to a percentage, we can express it as 50%. So, equal chance of happening, 50%. Then, the smaller a fraction, the less likely it is that the outcome will happen, right? Remember, looking back at the probability scale, 25%, I indicated there it's less likely that the event will happen, okay? And then when an outcome has a probability of half or 50%, it is more likely to happen than when it has a probability of a quarter, right? 25% or 1 over 15, which equates to 6.7%, for example. Okay, now let's put all of this into practice. Now I'm saying here, write down each of the following events on the probability scale where you think it should go. All right, now let's quickly look. There's our probability scale. Remember, starting at 0%, which represent impossible, moving all the way up to 100% being certain. Right, so question number A, it says, you win the jackpot in the national lottery. Sure, I'm sure all of us want to say that's 100% right, okay? But I would say that is less likely, okay? I think it's all left up to chance here. So therefore, I'm going to say A will be here. Okay? Remember our opening statement, the interesting part I share with you, right? About winning the lottery in our lifetime. Okay? We might be lucky, and you can say it's 100%, okay? If you play the lotto and you're lucky enough to win. Number B, you guess the winner of a rugby match correctly. Okay? So what do you think? Where will we place number B? Okay, that's true. Okay, I agree with you. That will be equally likely. Remember, there are two teams. Only one of the two can win. It's like flipping a coin, right? Equal chance of you being correct in guessing which will be the winning team in a game of rugby. All right? Now moving on to question number C. You will have a mathematical literacy test this year. Sure, I'm sure all of you would like to run away from it, but unfortunately, or fortunately for that matter, that is definitely certain. You guys will write tests, term 1, term 2, term 3, term 4, so that is definitely certain, 100%, right? And then lastly here, I'm saying a man will give birth. All right? Yes, definitely, I agree with you. So that is impossible. We know men are not made to give birth. All right? Guys, I hope this is all clear to you. Again, it's quite straightforward, but if you do the basics right, you will be able to apply it. Okay, let us quickly take a short break. After the break, we'll continue with more probability. See you now.